So we have the system being our block and our plane. We have a free body diagram showing the mg going directly down, the normal force coming out at an angle this way, and then we have an opposing force to that going directly opposite of that, and then we have the force pushing the box down the plane going in this direction. So I drew a triangle to figure out the x and the y, with the angle being 30 right here, and we know that our mg is our hypotenuse. So in the x direction, we have the force pushing the box down the plane, which equals mg sine of 30. And then in our y direction, which is opposing the normal force, we have mg cosine of 30. So we know that all the work being done is in the x direction because there's no work or no movement being done in the y direction. So for the first problem, we're going to find work being done on our object. So we have work equals force times distance. Our work equals mg sine of 30, which is our force pushing the box down, times 3, which is our distance. Work equals 44.1 joules. For the second part, we're going to find the kinetic energy at the bottom. So we're going to use the work energy theorem. Work equals the change in kinetic energy. So we know that our work is 44.1 equal to kinetic energy final, which we're solving for, minus our kinetic energy initial, which we know is 0 because the box was at rest. So our kinetic energy final equals 44.1 joules. For the last part, we're going to find what's the velocity at the bottom. So we use the kinetic energy formula, which equals 1/2 mass times velocity squared. So we know that our kinetic energy is 44.1. It's equal to 1/2, which our mass is 3, times velocity squared. We solve that and we get velocity equals 5.4 meters per second.